Daniel, you've been critical of a lot of things and you're just a flamethrower and then so on. What do you propose? I will tell you. I believe that if you're interested in science at all, even on a popular level, I will propose a couple of things that I think make a big difference. And I will tell you about our WellAI app that we've built that embodies some of these things. So, first of all, there are these things called general adversarial networks. What is a general adversarial network? It's actually very, very different from most of the models we ever did. It's adversarial because there's two neural networks kind of fighting each other. One neural network guesses something, the other one says true or false, right? Is correct or not correct. So this way you can try to, so one network generates a human face and the other one says if it's believable that it's a human face or not. They start with, so much as little blobs or something. So, I really encourage you to watch some of these videos on YouTube about GANs because they're going to change the way a lot of fields work. I think that in the machine learning aspect where we work, they're going to be very, very exciting. But I also believe they can help in genomics. So why? Because let's take a step back. Let's say that we have a computer and we want to write a program to generate a realistic human face without GANs, without what I showed you. Let's say you didn't see what I showed you. Look at the video. You see these faces changing? They start with a real face, but all of them are not real. These are not real humans. They're actually generated by a network. It's very hard to believe, I know. It's pretty unbelievable. So this general adversarial network can generate human faces that are very much believable, but they're not real humans, not real humans. Okay, so it can blend different humans and say create a hybrid of Albert Einstein and I don't know, Lady Gaga. I don't know what whatever. This is what it is, right? And that's really important. Remember what I told you the big problem was? The big problem was in genome is what? There's too much data. There's not enough data. There's too much questions to be asked, not enough data. General adversarial networks are really exciting because they can generate images, they can generate genomes. We can take, for example, a bunch of genomes of patients with a certain disease. Remember, a lot of in the old school way, you would take different parts of the genome. So let me look at this place and see if cancer patients have a mutation here. And remember what we saw in the previous slides. Genome is very continuous. There's no like discrete places. It's a fool's errand. You're not going to find much there. Sometimes you can, but it's very rare. But the general adversarial network, it generates a whole face. It doesn't just generate a part of an ear. It generates a whole face. So there's new research in the last year or two using these networks to generate genomic data. And I think it's extremely exciting. Why is it exciting? Because remember, this genome has so many different things going on inside that just dwarfs our understanding, boggles our mind. We don't understand it. Yet a large enough network doesn't have our preconception. It can just look at whatever is in there. It's not going to look at just this place. It can say, okay, maybe this place in the genome is related to this other place that's much, much far away, and all of them are related to yet some other third or fourth variable. And so because they're working in this way that doesn't that kind of transcends human understanding, it's just a big calculation machine. It can now generate some data for us. We can now bridge that gap to some degree, right? And the general adversarial network is really cool because it generates something, another network says true or false, and then it keeps going and until it gets really, really good at this. General adversarial networks, I would urge you to educate yourself on them if you're interested in science, because you're going to hear a lot about them in the coming years.